The Canadian Standard Math Assessment is taken by over 500,000 first-year university students every year. The test scores are always non-negative whole number values, so no half marks are given. Let x be the random variable that gives the score of a randomly chosen student who took the test. We know that x has a mean of 210 and a standard deviation of 10. Use a normal approximation to find the probability that our randomly chosen student scored less than 215. So in the question, they point out that the test scores are always whole numbers. So this is not a continuous random variable, it is discrete. So this x here is not normal. So that's why we have to use normal approximation. That's why this is a 4.4 question, not a 4.3 question. We have to be able to tell the difference. Because if you treat this just like a normal curve with its probability, you're going to mess it up. You're going to do something wrong. You're going to get the wrong answer. Okay. So, point out x is discrete. Okay, so x is a discrete random variable. Okay. So what we need is a good approximation. We need to flip things and change them so that they are working with continuous random variables with normal random variables. So we'll say that y be normal, and we'll give it the same mean, 210, and the same standard deviation, 10, as x had. Okay? Now, we've got a probability in terms of x that we'd like, but we can't calculate because it's a discrete random variable. We don't have a PDF. We've got nothing we can work with here. So we're going to trade this for a probability in terms of y. But that's going to be an area. What sort of area do we need? Right? Because it's not just copy it and have it be 215. Okay. So well, what do we do? So here's where a mock histogram is going to come in. So we might get 210 here. That's the mean, so that's sort of the peak. 211, 212. You don't have to fill them all in. All we want to do is sort of get a sense of where the area that we want, where the area representing the probability we are interested in, starts and stops. So I could keep going after 216, and if you wanted to, you could go back a little bit, but we're not too interested. Now we want the probability x is less than 215. So which boxes are going to be shaded? Is 215 going to be shaded? No. It's not less than or equal. It's got to be less than 215. So 214, 213, 212, basically everything to the left here. So the area, in terms of these rectangles, stops halfway between 214 and 215. And so that is what we'll compare y, our normal random variable, to. So now we want this probability. We just calculate this probability here, and using the fact that y is normal, we can now switch through. Oops, wrong button again. There we go. We can switch this probability in terms of a normal random variable for one in terms of our standard normal random variable. How do we do that? Well, you take the value you're comparing to, you subtract off the mean, which we know is 210, and you divide by the standard deviation, which we know is 10. So 214.5 minus 210 is going to be 4.5. Divided by 10, you'll shift the decimal place over. So z needs to have a value less than 0.45. And this doesn't require any other manipulation or trickery. Okay. No symmetries, nothing like that. We just look up 0.4 and then a 5. So it's going to be a probability of 0.6736. So that's the probability that z is less than 0.45, which is the same as the probability that y, our good approximation, is less than 214.5. And as we can see, thanks to our histograms, that is the same as the probability that our random student's score is less than 215.